Hi. I have my own business. One of my business partners suggested using clouds instead of local servers or infrastructure. But I am a little unsure. Why cloud?
Don't worry, I will be taking you through a knowledge bite on cloud computing, where we will learn all about it. In this module, you will learn about the cloud definition, the typical paramount characteristics of cloud ecosystem, the primary services offered by a cloud, the various deployment models for cloud, the inspiration for cloud, the difference between classical computing and cloud computing, the journey of cloud, the cloud edge over classical computing, and the architecture of cloud. The abbreviations and expansions used in the module are: IaaS represents Infrastructure as a Service. PaaS represents Platform as a Service. SaaS represents Software as a Service. VM represents Virtual Machine. VMM represents Virtual Machine Monitor. OS represents Operating System. Before we talk about cloud architecture, let's have an overview of what is cloud computing. What is cloud? In simple terms, cloud computing refers to the computation and storage. Definition of cloud. National Institute of Standards and Technology, shortly NIST, has various working groups drafting standards on cloud computing. The preliminary standard evolved from NIST is the definition of cloud computing, VIDE Special Publication 800-145, in the year 2011. Accordingly, NIST defines cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, for example, networks, servers, storage, applications, and services, that can be rapidly provisioned and released with minimal management effort, or service provider interaction. This cloud model is composed of 5 essential characteristics, 3 service models, and 4 deployment models. The cloud model composed of 5 essential characteristics starts with 1. On-demand self-service, 2. Broad network access, 3. Resource pooling, 4. Rapid elasticity, and 5. Measured service. The 3 service models starts with 1. Infrastructure as a Service, 2. Platform as a Service, and 3. Software as a Service. The 4 deployment models starts with 1. Private cloud, 2. Public cloud, 3. Hybrid cloud, and 4. Community cloud. The overview of essential characteristics, service models and deployment models will be discussed in the following section.
Sounds interesting. Now, I'm really excited to dive deep into this concept. How do we visualize a cloud?
Sure. But, before I visualize it, let me tell you the inspiration, which led to the evolution of cloud. We assume that we can plug and play and generate electricity when we move into a new home. But no one thinks about power plants and the electricity generation or distribution. That is taken care of by state electricity boards. Similarly, we want our business applications to be deployed and be available 24/7 without much of IT infrastructure in our business premises. We want complete utility. This is where cloud computing comes in. The invention of clouds is inspired from the electricity generation and distribution.
That's interesting. Is this a new invention?
Not really. In 1969 Letters. Klein Rock stated, as of now, computer networks are still in their infancy. But as they grow up, and become more sophisticated, we will probably see the spread of computer utilities, which, like present electric and telephone utilities, will service individual homes and offices across the country.
I am now wondering about the features of cloud computing. I'm sure they will be overwhelming.
Yes. you are absolutely right. Let's proceed and learn more about them. Let us now move ahead, and learn about characteristics of cloud computing. Click on each option, to learn more.
Before we jump into cloud, can you walk me through memory lane? I know we started with big mainframes.
Yes, let me cut the long story short. Over last 5 decades, computer hardware systems evolved, from mainframes to grid computing. Computer networks evolved, from telecom networks through Internet. And software architectures from desktop apps, through SOAs. All three have been used, in cloud computing architecture. Advantages of cloud computing include having a business continuity with ubiquitous access, a tariff for metered usage, minimizes capital expenditure (CapEx) on IT infrastructure, that is, cost reduction, on-demand and responsive delivery of services, quick rollout of services, elasticity, improved performance and scalability, dynamic provisioning and deprovisioning of resources, resource sharing, and optimization of resources, which includes automated management, increased collaboration, green computing and quick rollout of services.
Tell me, how is the cloud located?
Deployment models of cloud computing system are defined on the type of access to the cloud. Cloud computing advantages of cloud computing include having a business continuity.
Tell me, how is the cloud located?
Deployment models of cloud computing system are defined on the type of access to the cloud. Cloud computing systems have 4 types of access: public, private, hybrid, and community. Let me tell you more. Let's now know more about types of cloud. They are public cloud, private cloud, hybrid cloud, and community cloud. Click on each card to learn more. Upon gaining exposure to the essential characteristics, the 3 preliminary services are infrastructure as a service, platform as a service, and software as a service. Click on each service to know more.
So, I'm kind of visualizing cloud as data center over internet. Am I close?
Pretty close, but let's understand the difference between data center and cloud center. In a classical computing, the hardware, server and storage, software platform are dedicated for every users. Generally, on average, the resources are not utilized fully, leading to underutilization of resources, due to non-peak load, at most of the time. In cloud computing, the hardware and software resources are pooled together, virtualized, shared, and provisioned to multiple users, thereby leading to optimal utilization of the hardware and software components.
Can you please help me distinguish between traditional and virtualized environments?
Oh sure, come let's go. Flip each card to learn the difference between conventional and virtual environments.
Oh wow. I'm sure that I know everything about cloud computing now.
There is a little bit more. Come, let us learn about layers of a cloud, its constituents and so on. Let us now move ahead, and learn about layers of cloud. After gaining exposure to cloud, its characteristics, services and types, the layers for establishing and operating cloud environment is depicted. The base layer starts with hardware including servers, storage and network. The virtualization layer comprising hypervisor, sits on top of the hardware, responsible for virtualizing the underlying hardware, for offering services. The middleware layer responsible for all cloud functionalities. The service layer offering the provisioned services to users. The security layer, securing the entire cloud resources and services. And the management layer responsible for monitoring, metering, backup, SLA compliance, and related operational functionalities. The course is structured in a way. Cloud layers, hardware. The hardware layer comprises of servers, storage, and network. The hardware layer typically refers to data center. Managing the data center is dealt in the forthcoming session. Cloud layers, virtualization. Virtualization is the process of creating a virtual version of underlying hardware or software as an isolated service, using a specialized software named hypervisor. It is backbone of cloud. Generally, the cloud services are delivered on virtualization. Processor, memory, storage, and network components are virtualized to create virtual machines and delivered as IaaS. Application and database are virtualized to deliver SaaS. Cloud layers, middleware. This layer is the brain of cloud, providing functionalities like scheduling, orchestration, and management of cloud that controls underlying hardware and network resources. Cloud layers, service. Services layer is responsible for service delivery, user interaction, and control. Cloud layers, security. This layer secured the entire cloud environment, comprising of resources, services, and workloads. This includes server, storage network, operating system, hypervisor, middleware, application, database, and data security. Cloud layers, management. This layer performs operation and maintenance of resources and services, including monitoring, metering, compliance to service level agreements, backup, replication and recovery process, and user profile management. Cloud terminologies. The terminologies used in virtualized environment are as follows. The underlying hardware is termed as base or host machine. The operating system residing on top of the hardware is termed as base operating system. The software tools implementing virtualization is called as hypervisor or virtual machine monitor. The operating system within the virtual machine is the guest operating system. And the virtual machines are termed as instances.